Magnetic poles and fields. Here are your priming questions. All right, let's move on. Magnetic poles. The poles themselves are regions that produce magnetic forces. Every magnet will have a north and a south pole. Always both. And they come in many different shapes and sizes and forms and strengths. Here you can see just a regular bar magnet, which you're probably familiar with. We also have cube magnets, which we'll be working with in the lab later. There are cylindrical magnets, and these can be either magnetized through the side or through the circular ends. There are also spherical magnets, and we also have horseshoe magnets. Depending on the type of material or the alloy, and also the size and shape, can determine the strength itself of the magnet. There are some neodymium magnets that are very powerful for their size, some that can even lift hundreds of pounds, and maybe even thousands of pounds in some cases. So, what do these look like? So here you can see the magnetic field and the way we draw them. Okay, they go from the north to the south. Now, the north and the south poles cannot be isolated. And going back to one of your priming questions, I want you to think about why and what causes this. And so if we take a regular bar magnet, and you can see the field around it, depending on how you break it, so this is interesting, depending on how you break it, the two pieces would either attract or repel. So if we were to break it like this, there would be independent north and south on each side, and these would actually attract. So these two pieces would attract. Now, if we broke it laterally in this case, like this, we would have the north and the south be next to each other, and they would repel. So, as a quick note, opposites attract. So if we have north and south, they're going to attract, and like poles repel each other. All right. So magnetic fields. The magnetic field is the space around the magnet where the force is exerted. Okay, and so when we are drawing our magnetic fields, we always draw them going from the north to the south pole. An easy way to remember this is thinking of the way a compass works. And so we can work with our compass, and we're going to draw from the north to the south. And also, as a quick note, think about when something is facing toward the north, your compass, which pole of the compass is actually pointing north. We'll talk about that. And so, any magnet produces a magnetic field, and this is where the force of that magnetic field is exerted. Anytime you've ever worked with two magnets, and you can feel this pretty easily with two magnets, you can feel them either repel as they try to work against each other, or if you flip them around and they attract each other. There are some that are powerful enough to even go through the thickness of your hand or go through a table, and you can see the forces acting there. And so what we'll be doing in class is this will be a quick activity for you. You will be drawing magnetic fields. So you want to write this down because I'm not going to show this to you in class. So you will be required to make 5 drawings. Each of you will have to do 5 drawings. Each of these 5. So the first one, everyone's going to do all 4. And then the 5th one is a one that you get to choose. So a single bar magnet, then a single horseshoe magnet, 2 bar magnets with like poles facing each other, and you want about 6 to 8 centimeters between them. And then you want 2 bar magnets with opposite poles facing each other, again with 6 to 8 centimeters between. And then the last one is you can make your own combination. The only thing is, don't be selfish. We need to make sure we have enough magnets for everyone. So, how to draw your magnetic fields. We're going to be using these mini compasses that look very similar to this. And what you're going to do is you're going to start on either side, either north or south. And you'll start with the compass directly against the magnet. And what you will notice is that the compass will align itself to the magnetic field. And what you want to do is you want to draw a dot where it is starting from, right next to the magnet, as well as where it's pointing towards. From there, you will want to move the compass so that the tail end of the compass, of the needle, is on the last dot that you drew. And from there, and it should change, and so you'll notice it'll look like this. And so you want to put the dot on the tail end of the compass, And then you will want to draw a new dot where it's pointing towards. And then as you keep moving the compass like this, what you will notice is that the compass will continue to move, and something like this. And again, you want to align it so that the tail end of the needle is on the last dot, and you draw a new dot, and you keep moving it from there, and it'll keep rotating or moving depending on where the field is. And you just keep following it little by little, and you want to keep doing this until either it comes back to the magnet like this, or it exits the page. Now once you do this, you'll want to draw a line connecting these, and you will want to draw arrows showing the direction of the magnetic field. Remember, they go from north to south. Now for each one of your bar magnets, you want to have a minimum of 12 lines. And this will be per drawing. So a minimum of 12 lines. The biggest idea is you want to have a good idea of what the entire magnetic field looks like around this magnet. And so you'll be drawing these on a piece of paper. You'll have your magnet. Oh, I also need to mention that you should be outlining where your magnet is so that when you remove the magnet, the lines will make sense. And you also want to label the north and the south for each one of these. So once you do that, you connect the dots, you have your arrows, and hopefully after a set of 12 lines, you'll have a good idea of what the magnetic field around each of these setups looks like. And I'm hoping that you make an interesting combination. I'm hoping that you make an interesting combination so you can see what the magnetic field looks like around it.